I want to tell you a little bit. There's really four areas that we're going to discuss today. First is a background of the business. We're going to talk about our implementation and kind of get into some details and specifics around it. Talk about results. And I'm going to turn it over to Gary and let him discuss and detail how we've integrated theory of constraints and the Lean Six Sigma practices that we've had in place for quite some time to show how we're using those together and have integrated that into our business. And then we'll have some time for some questions. But first of all, the players. First, Delta Airlines. Delta Airlines, most people have heard of that. Started around 1928. Very large organization, about 50,000 employees, 1,700 flights a day, and about $17 billion in top-line revenues. So a large organization. The MRO, or Tech Ops, which is the maintenance arm, how did it get started? Kind of grew to facilitate maintenance for the airline. Clear cost center. It's very important for you to realize that today Tech Ops it's changing, but has always been looked upon as a cost center to the airline. But it grew to facilitate maintenance. About 6,500 employees. Our base is in Atlanta, a very large facility there. And we have about a $1.1 billion operating budget. And in both cases, these are very large and complex organizations that are oftentimes characterized as very slow to change. Some of you can identify with that, I'm sure. So those are kind of the players, and that's kind of what we're talking about here, and this is where we are. As Craig mentioned, we were in the throes of bankruptcy, which for those of you who have not had to go through that, you should thank yourselves and you're very lucky for not having to do that. These kinds of changes will keep you from having to do that, I can assure you. But that brings with it a lot of other types of pressures as well. And so we were in that. But one of the tenets that we had as we moved through bankruptcy, as far as what our organization would do, we wanted to grow the MRO aggressively. We wanted to be able to bring additional work in, provide services for other airlines, and through that be able to drive money right down to the bottom line, which was one of our core fundamentals, is to reduce the maintenance cost per airline seat mile for the airline. And so we needed to do that. And so engine maintenance was a great vehicle for that. And we had begun to insource several years ago, and I'll talk about that on this next chart, or next graph here. But engine maintenance, the complexity of it, what we actually do within our facility. We manage 6 different engine lines. I'm also responsible for landing gear, auxiliary power units, and thrust reverser overhauls. We do roughly 500 to 600 engine shop visits a year. We have 20 shared shops, so all those engines are moving into the repair process and are kind of managed through there. We have 4 test cells, about 1,600 employees, and about a $500 million operating budget. It's a great market. There's a lot of demand out there for the services that we provide. And we've been growing at probably 20 to 40% in some areas year over year. Drawing your attention to the slide here on the right kind of talks about our revenue growth, and I'll touch on that just briefly. You can see we've had about a 44% CAGR, compounded annual growth rate, since 99. In 99, we did about $20 million in revenue, which was really made that on a $1 billion business kind of a hobby. But you can see that that's grown to about $300 million, and I expect that we're going to be able to monetize some of the additional capacity that we've created through the process changes here to allow us to grow that at 20%. So those are pretty large numbers. Another important point here that I want to make is the fact that, as I said, we were originally a cost center for the airline, and there are a lot of people that still look at us like that. However, a big mix in our business has shifted to where 50% of the engines that we have in work today are from other customers. And so that fundamentally it drives us to have to think about things differently. And our senior leadership team is absolutely driving for more of a profit-centered thinking, and that's very different from cost-centered thinking. So those are just some of the points that I want to make around this. Very complex organization, however, can be very simplified through the process changes that we've talked about and that other people have brought to terms today. So if you're thinking about an implementation, you're just starting an implementation, simplicity can really be brought to complexity. How did things work before we began to implement? Well, we had 6 independent engine lines that brought engines in. Remember, we're satisfying the needs of the airline. Brought engines in independently based upon serviceable engine availability to Delta. So 6 independent engine lines would induct engines, so very unmetered demand. They would come in, get disassembled. Everybody would push those engines into the repair process, and we hoped, and oftentimes this didn't happen, that parts would come back. And then 2 weeks or so before we needed to build an engine, I kind of think of it, we just scraped parts together and got it done, And so that's kind of how things worked. And the challenges I think that we have had here were really threefold. The first one is parts weren't available when they were needed. That's kind of simple. JD talked about yesterday the fact that parts in an MRO are very important. And I moved into this business about a little over a year ago. And as I walked to my office, one thing that I noticed is that as I passed these parts, they all cost like more than my house. And it's not because I got a bad house. It's just that these parts are very expensive. So we can't just go out and buy them, especially as a bankrupt company, right? Because people aren't going to be very tuned in to allowing us to just go buy a whole bunch of parts so we can buffer inventory. So we've got to make sure that we're managing that as well. So parts not being where they need to be. The other thing is unmetered demand, and that's around WIP. Engines coming in and creating all this WIP, not only in engines but also in piece parts. And then thirdly, where these things are obviously tied together, is resources weren't available when needed. So those are really our three challenges, and I'm assuming that each of you in implementations are having the same kinds of challenges as well. Ajay also talks about the vicious cycle. And if you only have one vicious cycle, you should be glad. Because one's not enough for us. So we had two. And these two vicious cycles kind of did this, and then they created a Category 5 vicious cycle. And you definitely don't want that. But what we had vicious cycles that were kind of going around our assembly-disassembly process. We had a vicious cycle that was going around our repair and support process, and these two things combined together. And one thing that I noticed as I moved into this business, as the way it was run before I got there, is that a lot of that was driven by decisions that I was making, decisions that I was driving. And so kind of a big takeaway here is the fact that competing management objectives create uncertainty, and they sap capacity. And so you have to, as a senior manager or as a manager in your organization, you've got to realize what types of behavior you're driving in your organization that creates uncertainty. Because uncertainty in the front line around priorities and resource contention and those kinds of things ultimately take capacity away from your business. And I think that's powerful to realize that if there's a few things that you can change in the way that you manage your business, you can actually increase capacity with very little process change. A summary of our solution. Engines work like this. We basically assemble engines, disassemble engines. We disassemble them first. But we disassemble engines and assemble engines. These are very well suited for the critical chain project management methodology, which is basically low volume and high variability. Those parts then go out to a repair cycle, and then we expect that they come back and we assemble them again. The repair cycle is very well suited for a DBR application, drum buffer rope, and we've connected these two things together and implemented both of these processes, because that's a very high variability, high volume application. But what happens is that you've got current worst case parts that pace your lead time, and it may only be one or two parts. And it may vary as just as life changes through the cycle. It may not always be the same part, but you do have certain parts that are going to pace your engine visit, and we'll call those exception parts. So our solution here is critical chain on the assembly and disassembly side, drum buffer rope around those non-exception parts, and you see here where it says opportunity. That's how we are applying exception management around exception parts to make sure that we're doing certain things and very special things to those parts to ensure that we're following the 5 focusing steps of theory of constraints. One thing I do want to note is that a very complex environment, we as human beings, oftentimes when we see something very complex, we immediately jump to the conclusion that the solution to solve problems within it must be complex as well. And that's not really true. I find that few rules, few metrics, and simplicity is probably a better way to solve some of these problems, and that's certainly something that I've learned through this implementation. I want to get a little bit more into the details and specifics around our implementation. As I stated during the disassembly process, there's two things that are really key in this, and we manage this around buffers, and we make sure that our disassembly resources are applied based upon buffers. But there are two things that we want to occur here. And the first thing is those exception parts that come down and go into the repair process, either internally or to our outside repair suppliers, are down and out during this time. It's very important. We realize there's a lot of elasticity between a part being late, going out to a supplier a day late in the disassembly process doesn't translate into a day late in the assembly process. It translates into 4 or 5 days late. So it's very important for us to manage those parts. The second thing is we want to make sure that we've got a complete and accurate bill of material. A complete and accurate bill of material so we know what parts are due back. And we want to drive to more of a return-to methodology for all of our engines. Delta traditionally did a lot of swapping as we pulled those parts together to try to meet the needs. of the airline from a service level, but we wanted to move to more of a return to. So that's what we wanted to do during the disassembly phase. Then, very counterintuitive here, we want to hold parts. Imagine how this goes over when you're telling your disassembly team that they've got to get engines done faster and we're going to reduce cycle time. So remember how they couldn't get parts back and that's what was their biggest issue? So now we're going to tell them to hold parts. That kind of goes over like a lead balloon. And then you're going to tell them to hold parts in their area so they get to look at them for 15 days. So these were some of the challenges. But why are we doing that? I mean, we're doing that to reduce WIP, right? And Little's Law tells us that as we reduce WIP, so also we reduce turn time. And so that's why we did that, and we held those parts. So that's the main thing that we were looking to do during that process. And we have now gone to a centrally located release area where we've got really tight control over release of not only exception parts, but also non-exception parts. And then once we do release those parts into the system, we basically watch them every day and we compare them to how close they are to the assembly start date. And once they get to A-5, or 5 days prior to assembly, if those shop orders aren't completed, we turn them red. And so the real key and the simplicity around how we manage parts in the repair process is we prioritize them and we focus on throughput and turn time from our AMTs to go as fast as they can go and maintain quality. But we've prioritized them in expedites, reds, and everything else is work FIFO. So once they turn red, they bump to the top of the list, and that's how we manage those parts. So that's kind of a buffer. That's buffer management in DBR. And then once those parts come back, we're targeting A0, the A0 date, based on buffers. We don't start the assemblies until we have all the parts. Now, why is that? That's for us to reduce multitasking, right? Now, it's not that we have people just standing around, looking at parts that are 99% here. We have them deployed in other areas, right, based on buffers. So it's not that we're applying labor in a place that allows you to minimize overall lateness for your facility. And so that's kind of the methodology that we've applied, and that's the methodology that we've learned, and that's the methodology we've seen that certainly works. So this is an overview of our process. A summary of changes, and I'll go through these real quick. Created plans with buffers. Well, we've talked about that. We've made very aggressive buffers in the critical chain implementation. We've made very aggressive buffers in the parts release process, and Gary's actually going to tell you about kind of the next step that we're going to go to with regard to how we're managing the buffers for our piece parts. Control WIP. Obviously, everybody's kind of talked about controlling WIP, and the reason for that is for Little's Law and driving turn time down and throughput up. But controlling the release of those parts in the system, that was huge for us. We've seen some shops that used to be what we considered the bottleneck that had parts that were probably the size of this area, in queue, go to 0 queue, no parts in work at all. I mean, we've seen tremendous changes like that. And to see the people's attitudes change as they don't have this huge backlog of work, and they're able to have a little bit more stability around how they're doing their jobs is very, very gratifying for me. But we hold those parts until A-15, and we don't start assembly until all parts are available. So that's controlling WIP. Managing using buffers. Like I said, A-5, those parts turn red, and we change the priority of them in our repair process. Moving resources to where those tasks are red in the assembly-disassembly process. And then fourthly here, which is really key, is our exception management. I mean, that is really the key to all of this is exception management. And that's where at D+7 or 7 days after disassembly, we begin to really assign outside repair parts to those engines and begin to hard commit them. And then any issues that arise, parts that aren't available by A-2, we'll make some decisions around those that maybe swap or purchase or just accept the delay. Because sometimes it's cost prohibitive for us to save a day in turn time when some of these parts are $500,000. So that's kind of the summary of changes. Lessons learned. These are in no order, and by no stretch of the imagination is this an all-inclusive list. If I could, I'd probably put them all as number one. So I'll just go through these real quick. What we would have done differently, we would have certainly driven to a centrally released area, controlled released area a lot earlier. We didn't do this until 2.5 months ago. So we would have done that much earlier because that's had profound impact on our repair process. The second thing is we would have established a more robust process around managing the exception parts list, because that should be a living document, and we should be driving our foreman to reduce the parts on the exception list, whereas there's really this desire to increase the number of parts on the exception parts list because people want to make sure that they're getting their parts back. That's why the centrally released control area is important, because we had a lot of people who were saying, well, this one really should be on the exception list, so I'm going to release it. But putting a robust process in place to help us better manage that. Rolling out Concerto a lot earlier. We focused on drum buffer rope and the DBR implementation because, in all honesty, that was where our constraint was in the repair process, but we should have put Concerto in place a lot earlier. As it turns out, we began that implementation this year, and we started our total implementation in July, August of last year. So we should have rolled Concerto out a lot faster. Ensuring metrics were in place a lot sooner and taking a targeted approach to how we invested in inventory. Because we were in bankruptcy at the time, so we really needed to validate those purchases and make sure we were getting value from them. And this last one really, to me, is more of a takeaway than it is a lessons learned from all this. Management involvement is critical in exception management. You know, this isn't one of those things where you're going to say, let me go off and implement this, you guys let me know how it's going. You've really got to be involved in this. You've got to roll your sleeves up every day and be prepared to make decisions and be prepared to field the tough questions that are absolutely going to come at you. But management involvement is critical in the exception process. So let's talk a little bit about results. I'm going to put these in two terms before I turn this over to Gary. And the first element of results that we're going to discuss is kind of the engine level. And then the second slide is going to talk about the results that we've gotten in the repair and support process. But first of all, we had a 25% increase in engine capacity. And what we found is that the number of engines we had in work a year and a half ago didn't even support the demand. I mean, we couldn't even produce at that rate. And we had 20,000 open shop orders in our repair area at that time with 60 engines. So you can imagine 20,000 parts trying to keep up with that. But we had a 25% increase in just capacity alone. 23% increase in engine production. And what does that mean? You remember how I told you the way we managed before yielded about 40 engines a month? 40 engines a month of production. Well, now through the changes that we've made, we produce 50-plus engines a month. And to the point now where if we don't produce 50 engines, everybody's like, what happened? We actually, in June, we produced 63, and we didn't mean to. Didn't we do it on purpose? It was just what demand said we needed to do. So very gratifying. And we didn't crater production the next month as a result of that. We actually had a holiday in that month, and we were able to, I think we produced 53 or 54 engines that month, and last month it was 57. So we've really seen things kind of take hold. I look at this and I say, wow, that's good, but I have to also say, you ain't seen nothing yet. I mean, I believe that there's a lot more opportunity for us to be able to secure our futures through the things that we're doing. So by no stretch of the imagination do I look at this and say we're finished. Engine turn time reduction. You can see we focused on throughput a little bit more than we did turn time. Our next steps are going to be focused on cycle time and on-time delivery. But we've had about a 10 to 26% reduction in overall turn time on 4 of our 6 lines. Engine assembly, disassembly times, that part that's managed by Concerto, has had an 18 to 38% reduction in those times, and I think there's a lot more there to get as well. Revenue, as I'd stated earlier, our goals for revenue, certainly what we've done is we've allowed capacity to be monetized. Our sales team is very empowered to go out and fill this capacity, and we certainly have put ourselves in a position where we could achieve a 20% goal, and I think that our sales team and our senior leadership team is absolutely on the right track for that, so that's good too. Budget and production. In 2006, we had about a $484 million spend. This year our budget is $470 million, so we actually had a 3% decrease in cost, or available cash for us to spend, and we're tracking on that. It's a challenge, but anytime you've seen 20-something% improvement in production, to be able to do that without a whole lot of cost growth, and actually our plan being a 3% cost reduction is a challenge, but we're up for it, and we're actually headed straight down that line. A little bit of year-over-year comparison. This is before we implemented anything to the first 6 months of this year. Just a few different engine lines. The JT8D line, which powers the MD88s, we saw a 16% increase in shop visits that we were able to produce through the same period. 2037s, 46%. CFM 56-7s, you can say I think that's 65%. So big numbers. A lot of that's insourcing work too. We've grown that line tremendously. And the CF34, which powers our regional carriers, saw 66% improvement in throughput over the year from that period to that period. So those are kind of our engine results. The second part of this is our piece part results. We had a 50% reduction in WIP. We pulled out 10,000 shop orders out of our repair facility, and that alone, it's kind of like Linus with his comfort blanket. There are a lot of comfort parts in our facility. So when you're trying to pull those out, people find great places to hide them. And, so those are some of the things that you just have to go through and have to put very compelling reasons, and you have to drive that discipline it's courageous resolve and being consistent in what you say and then following through and realizing sometimes you make some mistakes and you admit those mistakes and you move on. So getting the whole team involved, allowed us to reduce that WIP by 50%. Let's see here, 25% increase in throughput within the facility and repair and support. So being able to do that with very little increase in capital or headcount. 92% of the parts now arrive at A0, which is the assembly start date. And it's actually been a little bit higher than that, but I can tell you a year and a half ago it was 0. We didn't even know what it was. But so that's a tremendous improvement. And our next steps here are really designed to get us to where we're 100% on time. 39% reduction in turn time within the repair and support process. So we took those processes down from 30 plus days down to well under 20. So large improvements there. And I look at these numbers and I think Darryl yesterday talked about the gratification that he sees when the front line really understands what you're trying to do, and then they kind of grab hold of it, and it's kind of satisfying. I look at these; they're personally gratifying for me. I'm by no stretch of the imagination an expert in any of these things, but I certainly know some, and I've got a phenomenal team that we all work together and supports this implementation. But I look at these, personally they're gratifying, but I also look at these results and I say, this right here is something that's applied and added certainty to our lives, because in 2006 and 2005, our operation was very uncertain. We didn't know what was going to happen to us. I look at these results and now I see people in the shops that are smiling and their faces are bright and they're happy about what it is that they're doing. And at the end of the day, they've got control over their destiny. So with that, I want to turn this over to Gary. And Gary, as you realize, I have tremendous respect for him. He's going to carry you through how we have implemented Lean and Six Sigma and kind of the history of that, and then how we've connected these two things together. And then he'll talk about our next steps, and then we'll be up for some questions. So,
good morning, ladies and gentlemen. I'm going to talk a little bit about the history of our continuous improvement efforts. I kind of shy away from discussing continuous improvement as a program because people tend to think that that's the next best thing, or how frontline employees interpret that. So this has been a huge learning curve, and I'm going to talk a little bit about integration, how we integrated Six Sigma, Lean, and theory of constraints, and how we integrated our continuous improvement program or our efforts into the business, how we partnered with Greg and the directors and the vice presidents. And then we're going to talk a little bit about the next steps. So in 1995, we started our first foray, would you say, into continuous improvement. This program was initiated in 95, and it provided about 3 days of continuous improvement training for every frontline employee. And every frontline employee that received the training, they had the opportunity to be a part of a team in their area. Pretty much like a suggestion box, but these teams would take these suggestions because in the past, frontline employees had great ideas, and typically these ideas fell on deaf ears. So we thought that the best way to handle that situation was to have frontline employees educate those frontline employees and put a little bit of that responsibility on the frontline employees. So we did the training, and actually it worked out very well. We had significant improvements in quality and cost, but I would say it was your typical incremental improvement, your 3 to 5% improvements year over year. So some years later, in 98, technical operations, we took that philosophy and we began to add to it. We saw the successes of that, and we called it a high-performance workplace. And we added some training. We added 4 or 5 more days of continuous improvement training, and we also what we saw that those teams lacked was facilitation skills, communication skills, and some more advanced improvement tools. So we provided those. And like I said, we continued that 3 to 5% improvement year over year. The CI program, or CI folks, or frontline, we initiated the lean. We went out, contacted, brought this training in. And at that point, we were starting to see more significant gains. And it was, it's very, very exciting to see as the culture changes and the education levels start to hit that steep learning curve, the things that can happen. And the organization recognized that. And at that point, they said, well, these people are becoming very valuable. It's in our best interest to make this a full-time position. So at that time, we made our master black belts and our black belts our full-time positions. And that really, that just sped that flywheel even faster. And over the next 5 years, we actually accomplished quite a bit. But quite a bit is never enough. But we were still just getting those 3 to 5% incremental improvements, which is great over a period of time. And like Greg said, through this learning in 2006, and it happened the same way, we brought theory of constraints into the organization, and it was done by middle management, or it was done by the CI program. It was something that as these people continue to learn, go out and visit other places, we bring this information back and try to embed it in the organization. And it's worked very successful for us. So in July of 2006, we began our implementation of theory of constraints, mostly around drum buffer rope and then critical chain. And we are continuing that effort a lot with Dr. Goldratt's thinking processes. We're adding that piece of it to our CI program. I would say that our master black belts and our black belts are really subject matter experts in all disciplines. I mean, there's some disciplines out there, I say all disciplines, very knowledgeable about Six Sigma, very knowledgeable about Lean, and very knowledgeable about theory of constraints. So how did we integrate Six Sigma, Lean, and theory of constraints? I wish I could stand before you and say it was a brilliant strategy. Actually, it was just a natural occurrence. Six Sigma just happened to be something that our senior vice president said, this is what we're going to do. It's a great idea, and I want to take this continuous improvement to the next level. I want to go from a hobby to actually using CI to create a tremendous business. So there really wasn't the tool usage, and as some of you know, if you've been through some of the training, a lot of the tools are very common. Six Sigma, if you're a Six Sigma black belt or master black belt, you learn a lot of improvement tools. You learn a lot about statistics. You learn a lot about the statistical tools. Very good at analyzing data. Lean provides you a method to create a visual workplace, pull systems, flow, stabilize the system, those type of things. And then TOC actually was actually the catalyst which gave us the opportunity to focus our efforts, because before 2006, most of and that was the reason for the 3 to 5% incremental improvements, because most of our efforts were focused locally, everywhere. It was everybody's choice as to what they thought the best thing to work on at that time. And it does add goodness, but it really doesn't give you that substantial improvement. And it really doesn't hit the bottom line when you have a CFO looking at it. Yeah, all that stuff's at 3 to 5%, but that's typically eaten up in noise. They weren't seeing a substantial difference in what we were doing. So TOC gave us the opportunity to focus our efforts. So thus far, our improvement efforts, or our TOC implementation, we've added a full quarter of production to engine maintenance. I mean, that's amazing. We went from a 3 to 5% incremental improvement to a 25% improvement. And you can bet the CEO saw that on the bottom line. So it's really opened up a lot of eyes with this pilot program. And our next steps, Greg mentioned that our repair and support internally was our constraint, so all the efforts were based on that constraint. We've eliminated that constraint, and we've identified the next constraint as our outside repair and our new materials purchase. And we're going to exploit that constraint, and part of the subordination is actually the next steps. Part of our subordination is to refocus attention on exception management. I can't emphasize how important it is on exception management, because an MRO environment pretty much is exception management. If you're not very good at that exception management, if your structure's not built for speed on taking care of those Murphys when they hit, you're dead in the water. So we're going to refocus our efforts and continue to improve on the speed of exception management, how fast we take care of issues. They have to be taken care of very, very quickly. Reduce cycle time of the disassembly. This is part of our subordination effort to our outside repair. Tear the engine down much faster than we are now. Get those parts to the vendor that have to go outside as quickly as possible. Like Greg said, for every day that we lose, it really adds, it compounds itself. For every day, we typically lose about 5 days on the assembly side. So if you're 3 or 4 days late on disassembly, you've just hosed yourself on assembly. And A-15. Our goal is to move to an A-10, release those parts 10 days prior to assembly, and those parts will turn red 3 days prior to assembly as they go through the system, to continue to reduce the whip in the system, to just make things move that much faster. And expand our implementation to include other products, which right now we're currently working on our landing gear shop. And we'll move into the APU shop and then into our thrust reversers. Typically, we'll move into base maintenance, which is our airframe aircraft repair. And not sure where we're going to go from there, but I'm sure it's going to continue to expand.
We have some time for a few questions.
Yes.
One right over.
Bill Faraday with Boeing. Greg, you mentioned that you reduced your turn time by 39%. You also decreased your WIP by 50%. Do you have an approximate value for the savings in inventory? And I imagine that turn time turns into flight hours, doesn't it? So that's additional revenue to Delta.
Yeah, the 39% reduction that you're talking about is in our repair process. And so that actually has improved our ability to start our engines on time and has allowed us to have a higher throughput. So really that's manifested itself in ensuring the fact that the airline can fly where it needs to. And if there is an incident or a requirement for an engine, it has it available. So it's really a risk reduction for the airline to be able to continue to fly the schedule. And through the summer was very, very, very difficult summer for us. We really flew those assets hard. So that's kind of how that manifested itself. And then it also created additional capacity for us to be able to insource engines from other customers. So that's kind of how that throughput improvement helped us. The approximate value for inventory, I don't have it on me, but I do know that it is. We're talking tens of millions of dollars, very, very large amounts of money that have allowed us to surplus that inventory and then purchase the right inventory. What we found is we had a lot of inventory, but it just wasn't the right inventory. So that's what we found. So I don't have a direct figure for you, and if you got a follow-up, I'll be around so you can ask me.
Yeah.
So I don't know if you want to touch on that.
Well, thus far I would say it's probably, I'll approximate about $12 million that we were actually just outright be able to get rid of. Like Greg said, we weren't able to monetize some of the inventory savings. Well, we are, because we don't have that inventory spend that we would have had. We're actually using those parts as we scrap parts out. We have that inventory that we'll pull from that area because we've actually taken that inventory completely out of the system and it's actually stored in another area. And as we scrap parts out, instead of repurchasing, we're just pulling that inventory back in.
Hello, Joanne Canetta again, Boeing Corporation. I have a question about quality. Is the quality and there's a lot of frequent flyers in this room, so I'm sure we really care about that. Is the quality organization part of your group? And do you answer to any external agencies like the FAA or any government organizations for the quality inspections of your work?
Yeah. First of all, for all of you that are frequent flyers in here or infrequent flyers, just to let you know that really Delta's core fundamental and foundation, just as the airline, but also the technical operations, is really around safety. It's core for us. It's non-negotiable for us. And we've really driven a compliance culture and a safety culture within our business. So those are things that we don't ever compromise. So you can certainly rest assured with regard to that. To answer your question around how the quality organization is set up, we had actually a lot of silos. You know, you had, as we talked about, 6 different engine lines inducting engines. We also had an engineering organization that was not part of us. We have a quality organization that was not part of us. What we had to do through this is create a virtual team. The quality organization reports to through another area of the business, very, very purposefully, because you do not want the quality organization reporting to the maintenance, organization because of conflicts of interest. But we have had to bring that team in and create them as more of a focused on quality as well as production. And the reason for that, kind of to your third point or your third question, is what agency do we report to? And that's the FAA. I mean, we're required by law to comply with those guidelines, and actually in most cases we over-comply with those guidelines. But we also, since we do work for other airlines and other customers, we also have EASA, requirements that we comply with, and as well as other regulatory agencies around the world. So did that answer your question?
Okay. One last question.
Hi, it's David. The question's really in 2 parts. The one is, was it well accepted when you had all of these different improvement methodologies, Six Sigma, Lean, and TOC? Was there any kind of sort of rivalry, or mine's better, or yours is better? And then the second part of the question is that if you had your time all over again, would you do it in that order, sort of Six Sigma, then Lean, then TOC, or might you do it the other way around?
Actually, you'll have, in any organization, you'll typically have your purist. Once we started our Six Sigma program, we created Six Sigma Purist, and we created Lean, we created Purist, but the whole idea is we kind of have, in some cases, we force that thinking. It's just all about education. The more educated you become, the more adapt to change you are. And we kind of forced that in our organization, because I had been to other organizations and seen kind of firsthand what would happen if I gave somebody a hammer and that's all they were supplied with. There's a lot of folks that, you could do all that with Lean. Well, yeah, I could put together an engine with an adjustable wrench and a hammer, but that'll make it right. So we forced that issue. And at this point, we pretty much, we don't have that purist. I think everybody understands now that the more educated they become, the much better position that we're in. And what was the second piece? The order, exactly. I hate to say it, but I would certainly use TOC first. It provides that systems appreciation. Dr. Deming talked about appreciation for a system, understanding variation, theory of knowledge, those type of things. And I think Dr. Gorett hits on all those very, very well, especially the theory of knowledge. How do you know what you know? And as we found out, we didn't know much of anything.
Every day you don't know every day.
I would start off with the theory of constraints, methodologies, get appreciation for the system and where to work, and then I would focus on the Lean and Six Sigma tools.
Okay.